here is another method that I just thought of to solve the same problem. So still giving this condition and trying to solve this quantity. So we can simply let x equal to tangent alpha and y equal to tangent beta. So let's find out x plus 1 plus x squared equals 1 plus tangent squared alpha equals 1 plus cos squared alpha sine squared alpha. That is equal to cos squared alpha plus sine squared alpha. That is equal to 1 over cos squared alpha. Now, then I have to apply the square root to that. So it becomes either positive or negative 1 over cos alpha, depending on the angle. So I just want to be very convenient. So let's just restrict alpha into an interval where that allows us to have a positive 1 over cos alpha. Now I can say let alpha and beta is restricted into an open interval of minus pi over 2 plus 2k pi to pi over 2 pi plus 2k pi, open interval. And of course alpha beta are not evaluated at the edges of this open interval. Since remember the unit circle. So we define cos as the x over the radius, but the radius is defined as 1, so the unit circle, right? So cos is defined as the x value. So if we want cos to be always positive, we just have to restrict the angle in between the right-hand half circle, right from here all the way to there. So in fact, here we have the angle of minus pi over 2. Up here we have the angle of pi over 2. So that is from minus pi over 2 all the way to pi over 2, where x value is always positive. It's on the right-hand side of the x-axis. And we also have to use open interval because we don't want the cos alpha to be 0 since it's at the denominator. So I think this restriction is just fine, but it's entirely possible that we have a minus with a negative value of cos when this angle alpha is restricted in the left-hand side circle of the unit circle, which is entirely possible, but since it's a very similar case, a very similar proof, very similar process, so I'm just going to leave that aside and just focus on this case. And this should be fine. If you want, you can discuss the other case if you like. I'm just going to focus on this case. So since square root over this is I already know cos is positive, therefore I can just write 1 over cos. So this becomes 1 over cos, and x is tangent. So I have tangent alpha plus 1 over cos alpha, quantity times quantity, tangent beta plus 1 over cos beta, quantity equal 1. And tangent alpha becomes sine over cos. And cos, we have a common denominator. So that becomes cos at the bottom. Top, we have sine alpha plus 1 times cos beta, likewise. Sine beta sine beta. Okay, plus 1 equals 1. And we can simply just multiply everything out. Multiply the bottom and multiply it all the way to the right-hand side. So on the right-hand side, we actually have cos alpha times cos beta. On the left-hand side, we have sine alpha plus sine. So sine alpha times sine beta plus sine alpha plus sine beta plus 1. And we can move the sine alpha sine beta over to the right-hand side. It becomes a minus term. So we have an angle sum, angle difference, or whatever. So remember, cos minus sine. Since it's a minus, we have a plus as the inside angle, which is cos alpha plus beta. If it's the angle sum of sine, then the sines have to be consistent. Since it's a cos angle sum, therefore the sine should be opposite, right? Cos minus sine. We have the opposite sign. We have a plus inside here, so this is fine. The left-hand side, we still have to copy down that. So sine alpha plus sine beta plus 1. All right. Now, let's see if we can further manipulate the equation. We can use, every time we see the sum of two different trigs, different signs, we can use so-called sum to product, STP, sum to product. So sine alpha can be written, I'll just quickly prove that. Sine alpha can be written as sine of half of alpha plus beta plus half of alpha minus beta. Let's just double check that. So alpha plus alpha, twice of alpha, plus beta minus beta cancel out. So twice of alpha over 2, so that's alpha. So exactly the same thing. So I can write sine beta into sine of half of alpha plus beta. I have the minus half of alpha minus beta. Alpha minus beta. Just double check that. So alpha minus alpha cancel out. Plus beta. Minus beta becomes plus beta. So twice of beta over 2. That's beta. Beta, the same thing, right? So this is fine. So plus 1, don't forget that. Plus 1 equals the right-hand side. Cos of alpha plus beta. We can simplify the left-hand side first, because this becomes angle sum. So angle sum is, so remember, sine angle sum becomes sine this times cos that plus cos this times sine that. Right? So it's just, so it becomes sine this angle cos second angle alpha minus beta plus, we have a plus sign here for plus. So then cos first angle sine second angle. Okay. And we can deal with this angle sum or angle difference if you want. So similar. So sine first angle, cos second angle. So sine first angle, cos second angle. Since it's a minus, it should be consistent. So minus cos first angle sine second angle plus 1 equals the right-hand side. We'll deal with the right-hand side later. Now, so we can cancel out something. So plus cos first angle sine second angle minus cos first angle sine second angle. They just cancel out. So simply cancel out that. Cancel. And sine first angle cos second angle, sine first angle cos second. So this is the same. So it just combines and becomes twice of this term, right? Plus 1 still remains, so we can quickly just erase. Okay, so we can just copy down everything here. So this term, that term, twice of this term. So twice of sine first angle cos second angle alpha minus beta, and plus 1 still here. Plus 1 still here equals the right-hand side. Okay, let's deal with the right-hand side. So cos alpha plus beta, I can rewrite that into 1 minus twice of sine squared of half of alpha plus beta. Again, that's just a trig identity of double angle formula. So where is our double angle? So I can treat half of alpha plus beta as a whole entity, as a whole angle. Twice of that angle becomes alpha plus beta. So here's my double angle entity. Double cos of some double angle equals 1 minus twice of sine square of that angle, right? It's easily verifiable. So we can now simply cancel out plus 1 and plus 1, right? And we have 2 and negative 2. Cancel out the 2's. Negative is still there. Don't worry about that. And we almost want to cancel out the sine half of alpha plus beta. We can't, because we don't know if that's 0 or not. Right? We have to do it the safe way. We have to rearrange it, bring it over there, here, and factorize everything out. So we can, so bring this term over here, becomes positive, and factor out the sine. Right? So factor out the sine of half of alpha plus beta. Bracket, we have this cos of half of alpha minus beta. We have since this becomes the left-hand side, and negative becomes positive, so plus sine of half of alpha plus beta. Quantity equals 0. So just like dealing with quadratic equations, we pretty similar. So discuss different scenarios. Case number 1, sine half of alpha plus beta is 0. In that case scenario number 1, sine of half of alpha plus beta is equal to 0. In this case, we can say that half of alpha plus beta must equal to 0 plus k pi. So equals k pi. Because remember, not only sine 0 equals 0, but sine pi is also equal to 0. So is sine 2 pi, sine 3 pi, and so on. So this is more rigorous, right? K is any positive or negative or 0 integer. So alpha plus beta is now 2k pi. And of course, beta can be written as 2k pi minus alpha. And then we want to find the quantity of x plus y, quantity squared. So x plus y becomes tangent alpha plus tangent beta. Tangent alpha plus tangent beta quantity squared equals what? So tangent alpha can be written as tangent to this. So tangent alpha plus tangent of 2k pi minus alpha quantity squared. And that is equal to, since tangent is a periodic function, so that is equal to tangent minus alpha. So, but tangent minus alpha can be written as minus tangent alpha, since tangent is an odd function. So tangent alpha minus 0. So that's our case number scenario 1. So case number 2. What if that is equal to 0? What if cos of half of alpha minus beta plus sine of half of alpha plus beta is equal to 0? Okay, in that case, move this term onto right-hand side. We have cos half of alpha minus beta equal to minus sine of half of alpha plus beta. So cos can be written as sine of pi over 2 minus the same angle, half of alpha minus beta equals minus sine can be written as sine of minus half of alpha plus beta. Since sine is an odd function again, so sine equals sine, angle equals angle. So pi over 2 minus half of alpha minus beta is equal to minus half of alpha plus beta. Of course, we have the plus 2k pi. Since sine is a periodic function again. Okay, so let's quickly just rearrange the equation. Let's see if we can. So this moved over there becomes positive. So alpha minus beta. Here we have a minus alpha so minus alpha minus beta. So this becomes positive alpha. Alpha minus alpha becomes 0, and we have a become minus beta from minus 2 beta over 2 minus beta. So here we have a minus beta plus 2k pi. There we have a pi over 2. So simply solve for beta. Beta is equal to, move this beta over here, move this pi over 2 over there. So beta is equal to minus pi over 2 plus 2k pi. But that is not possible, because we've just restricted alpha and beta into this open interval, and they're not evaluated at either edges, so not allowed to be minus pi over 2, right? But here we have minus pi over 2, that is the value of beta. So case number scenario 2 is not possible. So, but this is fine. We already achieved our desired answer from just case number 1. So this is actually 0.